Welcome to Naughty Notes. Well, let's explore three very common rotations, and we're going to do it, well, the same way we did with reflections. We're going to use the same pre-image, and that is in blue here, the triangle HJK, with the three vertices and three different quadrants to make it interesting. Now, these three rotations all involve rotating about the origin. Well, it's not going to work otherwise. And we are going to assume counterclockwise unless otherwise specified. Come on, all your math is counterclockwise. Deal with it. So let's get started. I'm going to take the first triangle, HJK. I'm going to apply this rule. AB is going to map to the opposite of B, A. So let's take this H, negative 3, 1. So therefore, H prime, opposite of 1, and the negative 3 remains the same. If J is 4, 3, J prime is going to be the opposite of 3, and 4 will remain. And if K is 6, negative 2, well, the opposite of negative 2 is 2. And then put in the 6. Let's plot that, see how it goes for the 90-degree rotation. H prime, negative 1, negative 3, so H is going to spin down there. J prime is going to be negative 3, positive 4. So far it looks so, well, over there. And K prime, 2, positive 6. Well, that looks pretty reasonable. We fill it out, it looks like that. And let's give it a spin. Perfect. Okay, well that's your 90-degree rotation, and of course counterclockwise. So let's go to 180. Now this one doesn't matter which direction, it's going to end up the same way. But, well, let's just go through the rule. AB maps to, well, opposite of A, opposite of B. How easy is that? If H is negative 3, 1, well, the opposite of negative 3 is 3. Opposite of 1 is negative 1. J is 4, 3. J prime, opposite of 4. Opposite of 3. K is 6, negative 2. K prime, opposite of 6. Positive 2. Now, let's plot these. 3, negative 1, down here. Ooh. No, it's actually on HK. Well, that's going to be okay. J prime, negative 4, negative 3. Negative 4, negative 3. So that's going to be down here. Okay. And K prime, negative 6, positive 2. Looks like we've got a bunch of collinear points. And of course we do. If we filled it out, it would look like this. And if I gave it a little bit of animation, there's our 180-degree rotation. One thing that's kind of interesting, you might notice, in the 180-degree rotation, every point and its pre-image are collinear with the origin. No, really. Well, it's easy to see here because all 4 of these, or all 5 of these points are lined up. But go ahead and just draw a little line here. And if you were to take your straight edge and you'd say, oh yeah, well, you know, those are all collinear. J prime, and the origin are collinear. Yeah, that's kind of cool. All right, so that's enough of that. Let's go to our third very common. That would be the 270-degree rotation. So again, we're going to take H at negative 3, 1. And that will map over to, let me see, make sure we get this right. I'm getting dizzy with all these coordinates. That'll be 1, and the opposite of negative 3, 3. If J is 4, 3, then J prime is going to be 3, negative 4. Okay? If K is 6, negative 2, then K prime will be negative 2. Negative 6. And let's plot that one. 1, 3, Okay, 3, -4. Hope I don't make a mistake. And then -2, -6 down there. Oh, well, that looks pretty good. So if we do that and give it a spin, hey, there we go. That is our 270-degree rotation. So there you go with a fair comparison of 3 very common rotations. A couple things to keep in mind. Remember, they're all going to be, well, they're counterclockwise, and we're all rotating about the origin. Here they are, all 3 of them at a time. That's kind of neat. Hey, how about this? How about if we let's make it fun. Let's trace those objects and give it a look. And there, that's a little visual, so maybe you can see the rotation a little bit better. Okay, well, if you're in my class, you'll be turning this paper in. If you're not in my class, well, I guess you're not turning it in. But regardless of why you're watching, I just want to say thank you for watching 90 Notes.